All right, cool. So in this next one here, we are looking at the second example of that bond calculation. So I'm just going to label this as number 2. So basically, in this example here, instead of giving you all the enthalpy values for the different types of bonds, they leave one out, but instead they give you the enthalpy value. So with all of this, it's just algebra. One thing is missing, you just solve for x. So let me show you how to do this second version. When it comes to the assessment, they're going to do basically one of these bond calculations and one of these questions, or maybe 2 of these questions. And it can be any combination of what you see here. So you need to know them all. All right, moving on to this question here. So you can see what I'm saying. An unknown bond example. Ooh, hopefully you guys can see that. Okay, I might move that a little bit to make that bigger. Whoops, too big. Okay, wow, too small. Okay, you can kind of read that. I'm going to rewrite it on the piece of paper anyway. All right, so what they have done once again is that they have given me a reaction. They have actually done something weird. They've given me a half N2 plus a half O2, and they show me that it makes NO. Unusual they've done that, but you can still work with it, and I'll show you what you kind of do with that. They've given me all, let me do the labels again. So those are my reactants. These here are my products. And they've given me certain values. So what they have given me is the N triple bond, N, which is that guy there. And they tell me that's 9, 4, 5. They've also given me the O double bond, which they say is 4, 9, 8, which is that one there. And this is the one that's the unknown, the question mark, the X. And they've given me that the delta H value is equal to 90 kilojoules per mole. So what we see here in this equation, and they want us to solve for the N triple bond. So what we see here is a slightly different layout of the information. All we're trying to do now is just solve for X. We set it up in exactly the same way. We're just going to substitute X as our number. So in fact, I might make this bigger so you can see the whole thing because the question's now copied down. All right, so with the reactants, we have a half of N2, and we're just going to multiply that by the number. And we just have a half because we're taking those coefficients in front. And we're taking the double bond oxygen. So that's all you do. You literally, even if you have a funky number like a half, in level 3 chemistry we'll explain why you're able to do a half, but the main thing you got to know is that you can't do that. And basically all we're doing is taking our numbers and dividing them by 2. So that's 4, 2, 5, and then the most likely mistake you're going to make is a calculator error, so please double, triple check things. All right, cool. Add those 2 numbers together. So that is what I have as my reactant number. All right, now here comes the complicated thing. I look here, there's only 1 for the N triple bond O times we don't know, so it's just 1x for that case because there's no non-1 number there. So let's set it up like we normally do. What we would do is we would take the reactants and we'd subtract away the energy released from the products, in this case X, and we're actually going to set it equal to the enthalpy value because that is what we have been told, like that. So in our previous examples, we would just do the subtraction and figure out our enthalpy. Enthalpy was acting as our X. In this case, this is our X. So now we treat it like we would any algebraic equation. Whatever I do to one side, I need to do the other, and we're trying to do opposites to remove things. So that's going to get rid of those 2. And we're doing 90 minus 721.5. So that equals negative 631.5 equals negative x. They're both negative, so change them positive. X is equal to 631.5. I want to have 3 significant figures in my answer, so I look and I go, okay, 1, 2, 3. That's the number I need to decide what to do with. I look over here, it's 5, so I round up. So my N triple bond O is going to be 632 kilojoules per mole for that reaction. And this should always be a positive number, just FYI. So that's how you do it that way. Going back to our little PowerPoint. I have a second example. Zoom up in here again. So I always like to give 2 examples just so that way you guys have a couple ways to kind of see it. So if you want, pause the screen here so you can give that question a go, and then I'll go through the answers. If you're feeling really confused, you can just keep on watching. Okay, let's do this one. So let's go back and do what I was doing before, and it didn't like that. Now it's liking that again. All right, and let me make that a little bit bigger. And make that a little bit smaller. I think I actually had steps for this. Did I? No, I just jumped you straight into it. Okay, that is fine. Okay, so let's get working on that one. So we have CH4 plus NH3. This one's a good example because it's a little bit more complicated. And 3H2. So again, reactants, products, let's work our way through it. They have told me that this CH bond is 414. This one here is what we're solving for, and H, that is our question mark. So that's going to be our X value. What else have they given me? This one here, I'll actually draw out the molecule for you once I can remember what it looks like. C triple bond, that's what it looks like. That's what that molecule is. And they've given us, again, that CH bond 414, and they've given us the C triple bond N, and that is 860. And then the last thing they've given us is the HH bond, which is 436. And lastly, they told us that delta H is equal to 247. And like I said, we're solving for that NH one. So let's get set up. Now this one is a little bit more complicated because there's lots of more moving parts in it. So let's list this out. Actually, let me draw it out first. So for the CH4, that's what that molecule looks like. So if I was to count out how many bonds I would have, I have 1, 2, 3, 4 of the CH bonds. And we're multiplying that by 414. Cool. The other one we have is our ammonia, which is that here. Now in this case, we have 3 of them. When I count them, 1, 2, 3. But this is my unknown. So this is my question mark. So that's my unknown that I'm solving for. So what I'm going to do is take that question mark and multiply it by 3. So what I'm working with in reality is 3x, because I have 3 of the hydrogen-nitrogen bonds. So when I put it together, I actually have 1656 plus 3x as my answer for that. And that's okay. We're going to plug that into the equation and use it as is. This one here, I've already drawn out, but I'll draw it out anyway for consistency. So when I look at that, I have 1 CH bond times 414, so that equals 414. I have 1 carbon triple bonded to a nitrogen. That value is 860, so I'm writing that down. And then when I look over here, I have 3 hydrogen molecules. So when I go out to count, 1, 2, 3, 3HH times 4, 3, 6. 4, 3, 6 times 3 is 1308. And again, I just add them together like I do with the previous problem. And I get 2582. Oopsie. There we go. All right. So last step then is just like we were doing before. We take the reactants, we subtract away the products. In this case, I have 1656 plus 3x minus 2582 equals to my enthalpy value they told me, which was 247. It's your call how you want to attack it. Personally, I like to put all my numbers together. So that way I know what I'm working with. Just clear that. So actually, I'll just do 1656 minus 2582, and I get 3x minus 926 equals 247. I'm adding that to both sides. So that way that cancels out. I add those two numbers together. I get 1173, and that is equal to 3x. I want to get rid of that 3, so I divide both sides by 3, because again, we're just doing some algebra. That cancel out. X equals 391. So the nitrogen-hydrogen bond is equal to 391. That's already in 3 sig figs kilojoules per mole. And that's how I got that answer there. So that's how you do those questions. All right. Next one.